the universe will come to an end. Everything, every star, every planet, every atom is racing toward its inevitable destruction. Time is dragging the cosmos toward a final, catastrophic fate, and there is one possibility that stands out as the most violent: the Big Rip. A future where the very fabric of space is torn apart, where galaxies unravel, where stars and planets are torn apart, where even atoms themselves are shredded into nothingness. This is not just the death of the universe, this is total annihilation. The Big Rip is perhaps the most unsettling yet fascinating of the three theories regarding the ultimate fate of the universe. Unlike the slow, cold demise of the Big Freeze or the violent rebirth of the Big Crunch, the Big Rip suggests something far more dramatic: a final, accelerating expansion that tears the universe apart, molecule by molecule, until even the concept of space ceases to exist. To understand the Big Rip, we need to start with what we already know about the universe's expansion. Ever since renowned astronomer Edwin Hubble made his groundbreaking observations in the 1920s, we've known that the universe is not sitting idle. It's growing, stretching, expanding outward in all directions. At first, scientists assumed gravity would eventually slow this expansion down. Maybe in time it would even reverse, leading to a big crunch, where everything collapses back into a singularity. But then something was discovered that was unexpected. In the late 1990s, observations of distant supernova revealed that not only is the universe expanding, but that expansion was actually speeding up. Something mysterious and powerful is pushing galaxies apart at an ever-increasing speed. This force, dubbed dark energy, makes up roughly 68% of the universe's total energy content, yet we still have no idea what it actually is. The more we study dark energy, the stranger it becomes. Unlike gravity, which weakens with distance, dark energy seems to remain constant. But if dark energy grows stronger over time, its repulsive force would eventually overcome all other forces in the universe. This wouldn't just cause galaxies to drift apart, it would accelerate expansion to such an extreme that, one by one, galaxies, stars, planets, and even atoms themselves would be torn apart, unraveling reality at its most fundamental level. So how does this cosmic nightmare play out? The answer lies in how dark energy behaves over time. If dark energy remains at a steady level, the universe will continue expanding, but in a manageable way. But if dark energy's strength increases, as some models suggest, then its repulsive force will eventually overwhelm all other forces in the universe. The Big Rip follows a terrifying timeline. A few billion years before the end, the expansion of the universe has accelerated to such an extreme that distant galaxies become unobservable. Their light is redshifted beyond detection, meaning that if any intelligent beings are still alive, they will see nothing but the stars of their own local galaxy. The vast cosmic web that once connected galaxies begins to unravel. A few million years before the end, gravity, which has held galaxies together for billions of years, starts to fail. One by one, galaxy clusters break apart and the individual galaxies drift away from each other into the endless void. Eventually, every galaxy, including the Milky Way, is torn apart, scattering stars and planets across the cosmos. Days before the end, planets and stars themselves succumb. The forces that bind solar systems break down. Planets spiral away from their stars, with the stars themselves beginning to disintegrate as the nuclear bonds within them weaken. Minutes before the end, the destructive force of dark energy overtakes the atomic scale. The electromagnetic forces that hold molecules and atoms together are overwhelmed. Atoms are ripped apart into subatomic particles, and in the final moments, even those particles disintegrate. The final instant arrives, and space-time itself is torn apart. There is no more distance, no more time, just a final, absolute dissolution. The fabric of the universe ceases to exist. And then, there is nothing. It's one thing to imagine the death of our sun, or even the end of our galaxy, but the Big Rip suggests an ending that is far more absolute. an unraveling of existence itself. Unlike the Big Freeze, which suggests a slow fading into darkness, or the Big Crunch, which could potentially lead to a new universe being born, the Big Rip offers no such continuity. It is a total, irreversible annihilation. What happens to space and time if the very framework that defines them is destroyed? Could there be something beyond the Big Rip, some other form of reality? Or does existence itself cease in every conceivable sense? From a human perspective, these questions feel deeply unsettling. They force us to confront the idea that the universe, which seems so permanent and vast, is not eternal. More than that, it suggests that even the laws of physics, the very things that govern reality, are not immutable. They can change, they can break, and ultimately, they might even self-destruct. For now, the good news is that if the Big Rip scenario is correct, it's billions of years away. Current estimates suggest that if dark energy is growing stronger, it's going to take at least 100 billion years before things get truly apocalyptic. That's far beyond the lifespan of Earth, the Sun, and likely humanity itself. But the unsettling reality is that we still don't fully understand dark energy. It could behave in a way that is unpredictable. Some physicists speculate that changes in dark energy's properties could accelerate the timeline. Others suggest that the Big Rip might never happen at all, and perhaps dark energy will stabilize. Perhaps something else entirely will take over the fate of the cosmos, something that we do not see as of yet. Whether or not the Big Rip is the fate of our universe, the idea forces us to think about the impermanence of everything. The universe, for all its grandeur, is not eternal. Like everything else, it has a beginning and, quite possibly, an end. But does an ending confer a sense of meaninglessness? Or does the very fact that we exist now, in this brief window of cosmic time, make our existence more profound? The Big Rip, if it happens, is billions of years away. We are fortunate to live in a time when galaxies still shine, when planets still orbit stars, when life, at least in one small corner of the cosmos, has the chance to think about its own place in the grand story of the universe. Perhaps that's what truly matters, not how the universe ends, but how we use the time we have before it does. As we look up at the stars, as we ponder the mysteries of the cosmos, we should remember, the universe may be temporary, but our curiosity, our wonder, our desire to understand, it is these things that give meaning to existence, no matter how it all ends. We hope you enjoyed spending your time with us exploring the Big Rip ending of the universe, and invite you back for our next episode